In this part of the video, I will do these VCAA problems on discrete random variables. So let's get started. Discrete random variable x has the probability distribution this, and they want the value of p. Right, so all we'll do is we'll go p squared plus p on 4 plus 4p plus 1 on 8. We know that they have to equal 1, and then what I'm going to do basically is solve for p. So you can see that this will form some form of quadratic. Okay, so the next thing I'll do is knock out the denominator with a multiply by 8 across the left and right hand side. So I've got 16p squared plus 2p plus 4p plus 1 equals 8. Then I'm going to do 16p squared plus 6p take away 7 equals 0. Okay, fairly nasty looking one here, but this will be an exam one question, or this is an exam one question. So we're expecting this to factorize fairly easily. So I'm just going to use the cross method and suggest that it would be 8, 2 to get the 16, so 8p and 2p, 14 and so we've got 7 and 1, 7 8's 56, so 7, I think that's it, 7, 1. That's going to be 8p, 14, the difference is 6. Excellent. So that is going to be 14, that's going to be the negative. So we've got, let's just double check that. That's going to be 14p. This is going to be negative 8p, which equals 6p. Yeah, we got that right. So then we've got 2p take 1, and we've got 8p plus 7 equals 0. P equals negative 7 on 8, which we're going to reject. Get that more looking like a negative. Reject. And P equals a half. And there it is. So find the value of P. All right, this one. The number of pets X owned by each student in a large school is a random variable with the following discrete probability distribution. If two students are selected at random, the probability that they own the same number of pets is. Right, so same number of pets means that they own 1 and 1 pet, 2 and 2 pets, 3 and 3 pets. So 1 and 1 would be 0.25 times 0.25, 0.2 times 0.2. This one's going to be 0.05 times 0.05. All right, so again, the way I'm imagining this is done on a tree diagram. So 0, 1, 2, 3, and then 0, 1, 2, 3. And what I'm looking for is same number of pets. So that would be 1 pet and 1 pet, 2 pets and 2 pets, 3 pets and 3 pets. I'm looking for these three specific branches. Okay, because it's a multiple choice, we can use our calculator. So that's going to be a quarter times a quarter, which is going to be an eighth. Plus 0.2 times 0.2 is 0.04, plus that, oh, I don't trust myself with that. Plus 0.04. Okay, I suppose what they're saying here is that we consider 0 and 0 the same number of pets, i.e. I don't have any pets and I don't have any pets. So that would be 0.5 times 0.5, which is 0.25. So I'm just going to check that. And that is it. Okay, so lucky that that first one wasn't a distractor, 0.105. So the wording's quite important here. The probability that they own the same number of pets. So I've gone on to assume that they actually own a pet, but the same number of pets could be, well, I don't own any pets. How many pets do you have? I don't have any pets. Oh, wow, we've got the same number of pets. None. Okay, so yeah, this does meet the requirement. Alrighty. Okay, so this is exam one. On any given day, the number X of telephone calls that Daniel receives is a random variable with a PDF given by. Okay, find the mean of this. Okay, so we're not worried about the mean of the random variable at the moment. That's next lesson. What is the probability that Daniel receives only one telephone call on each of the 3 consecutive days? So we've got one telephone call happening on each of the consecutive days. So that's going to be 0.2 times 0.2 times 0.2. So again, if you imagine the branches, we can get 0, 1, 2, or 3. And what he's basically doing is getting one phone call, and then one phone call. So that's a very particular branch on the tree diagram. Now that's going to be 2/10 cubed, which is the same as 1/5 cubed, which is 1 over 5 to the 3 is 1, 2, 5. So 1 in 125 chance of that happening. Okay. Daniel receives telephone calls on both Monday and Tuesday. What's the probability that Daniel receives a total of 4 calls over these 2 days? All right, so how can he get 4 calls? He can get 4 calls by getting one phone call. So let's break it up from Monday and Tuesday. We can get one phone call and 3 phone calls. We can get 2 and 2, or we can get 3 and 1. So there's 3 possible ways that can happen. All right, so let's do 1 and 3 first of all. So that's going to be 0.2 times 0.1. 2 and 2 is 0.5 times 0.5. And this one is going to be the same, just in reverse order. Okay, so this is going to be then 0.02. This is going to be 0.25. And this is going to be 0.02. We're going to sum them together and we're going to get 0.29. Okay, so what is the probability that Daniel receives a total of 4 calls over these 2 days? And you'd think that this would be the right answer, and it won't be. Okay, now the reason for that is we're told that Daniel receives telephone calls on both Monday and Tuesday. So if I asked you then, what is the probability that the random variable equals 0, okay, given this information here, you would say there's no chance of it happening, okay, because what do we know? We know that he received phone calls, okay, so that's the really important piece of information here. So this, again, is very subtle conditional. Okay, so they haven't said the words given that. Okay, and yeah, I don't know. Usually VCAA do use the words given that. It's usually pretty obvious, but this one's much more subtle. So what we're going to do is we know that this is the probability that he receives 4 phone calls. Okay, and all we're going to do is then divide it by the chance of him receiving a call on Monday and Tuesday. So the chance of him receiving a call on Monday and Tuesday, so receiving a call on Monday is going to be 0.8. So let's work out, so Monday and Tuesday, chance of him receiving a call on Monday is 0.8 and receiving a call on Tuesday is 0.8. That gives us a probability of 0.64. Okay, so now all we're going to do is do 0.29 over 0.64, which is 29 over 64. So that one would have been a very difficult problem. I think state wouldn't have gone well. So maybe look up the examiner's report on that one, see what the state got. it would have been quite low. All right, so there's your work for today, folks. All right, so good luck with that, and I'll see you back at the ranch on Thursday.